So I am at Skimlinks, which is why I'm going to give you the most important slide right at the beginning, which is this. And you'll see why I need to say this as I go through the talk. So I'm just going to start off by explaining what an A/B test is. So typically, an A/B test will be used to figure out whether one version of a website performs better than another version of the same website. And people are often interested in whether more people purchase, that you get more conversion events on one version of a website compared to another. So one example would be you want to test out, you want to change your free delivery, you want to change your delivery policy, and you want to give free delivery to some people, but you want to check, first of all, that it's actually going to make people buy more stuff. So you'll set up one version of the website where you offer free delivery and another version of the website which is just as it was before. The control version, then people would not see anything about free delivery, they just see the regular website. And the variant version, people will see the free delivery, you'll check. If people buy more stuff, then you implement the free delivery because it's obviously going to make you more profit. So that's just simply one A/B test. So when I told someone that I was going to be talking about A/B testing here, a colleague, this is the question he asked. He said, how can you talk about 40 minutes about A/B testing? It's just you get the A and the B and you just test them and you figure it out, and it seems simple. So the reason is I think that A/B tests are really easy to get wrong. And in fact, I think most people in the industry get them wrong. And so this is based on my previous position as a head of research at Qubit, which is an analytics technology company. And I oversaw A/B tests for large e-commerce clients. So some of the biggest ones in the world, people like Staples, John Lewis, Topshop. And I looked at results from hundreds of A/B tests. And I spoke to lots and lots of people about how they're doing A/B testing in-house. So I also talked to this guy who used to work in a large auction site that we've all heard of. I won't say who it is. And he's told me some of the things that happened there. And I'm just going to be talking about a few different informants from different companies. But the story that he told me that I thought was quite funny was that they wanted to improve their search algorithm. So they did an A/B test, and they found that the new version of the search algorithm improved conversions by 2.5%, which was great. So they obviously were moving to implement the new version of the search algorithm. Everyone was really excited and patting themselves on the back until someone figured out that there was a bug in the A/B testing code, and in fact they weren't even testing the new version of the algorithm, they were testing the same version against itself. So that was just a complete waste of time. So I'm going to talk. The talk really hinges on 3 statistical concepts that I think everyone needs to know. I'll talk about some of the errors that you can make if you don't keep these concepts at the top of your mind. And then I'm going to argue that actually most A/B testing software is designed in such a way that these errors are virtually guaranteed to happen. Because of that, most positive results are actually going to be false. So people are just walking in the dark with this stuff, I think. So these concepts are statistical power, multiple testing, and regression to the mean. So I'll start with statistical power. So statistical power, probably most of you are familiar with this, but it's the probability that you'll detect a true effect between 2 samples. So it's a true effect. If there really is if there really is a difference between the 2 measurements that you're making, between the A and the B conversion rates, for instance, what's the probability that you'll actually see that effect when you do the test? So let's say you're trying to figure out whether men were taller than women on average. You'd naturally measure the heights of some men and some women, and then you'd do some kind of statistical test to see whether men were taller. Now, if you only measured one man and one woman, you wouldn't have any statistical power, and that's because you might just by chance measure a particularly tall woman or a particularly short man. Your statistical power will be very low. Now, if you start to measure more people and take averages, eventually the averages will start to stabilize and the picture will become a lot clearer, and you'll see that men are, on average, much taller than women, a little bit taller than women. So the same thing happens with this example of free delivery, an A/B test on a website. The more people that come through your website, that go through your test, and the more conversions that happen, the clearer the picture becomes, and the more likely you are to see an effect, if there really is an effect to be seen. So statistical power is important, and there's two reasons why it's important. And everyone gets the first reason, but I think that most people don't think about the second reason. The first reason is that you'll just get lots of false negatives. If your power is low, and power you normally express as a percentage, so the probability that you'll detect an effect if there really is an effect could be 50%, let's say. It could be lower, it could be 10%. If it's 10%, you're going to have lots of false negatives because there are going to be lots of true effects that you just miss. You don't detect them in your tests. And that's bad. It's kind of a waste of time. It's not ideal, but it's not the end of the world. There's much worse effects, which is that the number of false positives or the proportion of false positives in your results will also go up. And that's something really important that I think is often missed. I'll show that here. So I want to introduce this concept of precision. That you may or may not be familiar with, but it's the proportion of true positives in the positive results. So you perform your, in this case, A/B tests. You get some positive results, some negative results, and if you just take all of your positive results, there are going to be some of those results which are true positives, and some of them are going to be false positives. So precision is the proportion of true positives in the positive results. It's a function of power, significance level, and prevalence. I'll talk about significance level. Prevalence is just how likely you are to have a true effect. So this, in medical research, this is called positive predictive value. You might have heard that as well. Medical research is really important because there's lots of diagnostic tests that people do. If you do a test for tuberculosis, you want to know if someone has a positive result for tuberculosis, what's the actual probability that they truly do have tuberculosis? And you need to know what the prevalence of tuberculosis is in the population that you're testing in order to make this calculation. So in our case, we're looking at websites. A good rule of thumb is that 1 in 10 tests have a true effect. So people from Google and Amazon have looked at this over thousands of tests, and it seems like a reasonable rule of thumb that 1 out of 10 tests have a true effect. Some tests are going to have a negative effect. Most of them are not going to have any effect. And in the data that I've looked at, over hundreds of A/B tests, this seems to ring true. So what does it mean? So let's say you've got good power. Good power would be 80%. You've got 80% probability that you'll see an effect if there truly is an effect. So if you ran 100 tests, 10 of those, like 1 in 10, is really going to drive uplift, is really going to have a higher conversion rate. You're going to detect 80% of those, which is 8. And you'll have 5 false positives. And this goes back to the significance level, but most people set their significance probability to 5%. And that's the probability that if there's no effect, you'll see a positive result. You can't avoid that in any statistical test. There's always a possibility that you'll see a positive result when there is no real effect. So let's say you have 5 false positives. You detect 8 of the true effects, so 8 out of 13, that's like 63% of your positive tests are real. So in practice, that means that if you implement all of the positive results in your test on your website, only 63 of those changes were actually valid, and the rest were a complete waste of time. That's if you have good power, but let's say you have got bad power. So this is let's say the original test, you did some calculations, and you found that you needed 2 months to run your A/B test. And then your manager says, well, that's just not good enough. I want to run this I need the results in 2 weeks. I need to speak to the boss. I need to get the results in 2 weeks, which is common. You'll now have 30% power. If you originally had 80% power, you'll now have 30% power with a sample size a quarter of your original that you originally calculated. So your false positive, you're going to get 5 false positives again. That stays constant. And you'll only detect 3 real results. So you've got 30% power, you only detect 3 of the real results. So now 3 out of 8 of your winning tests are real. I should say that this is the 63%. 63% of your winning tests are false. So 3 out of 8 are real, 5 out of 8 are false. So the majority of the tests that you now go and implement on your websites are false. Possibly neutral or possibly have some negative effects on your profits. So this is why this happens. I completely sympathize in why people run tests at very low power. Because the marketer, I've had lots of conversations like this. The marketer says, we need results in 2 weeks' time. Or the statistician says, we can't run this test for only 2 weeks. We won't get robust results. and the marketer says, why are you being so negative? Can't you do something else? And I've had loads of conversations like this, and you can just try and educate people. So what should we do? We should try to calculate power before we do any tests. This is something which has to happen if you're trying to test in this kind of classical statistical framework. So I mentioned significance level. This is also sometimes known as the alpha, and it's the probability of a true result when the null hypothesis is true. In this case, the null hypothesis would be that there's no difference between the A and B version of the website, that they perform equally. So the alpha is the probability that you'll see a positive result under these conditions. There's no true difference. The beta is the probability of missing a positive result. This should be when the null hypothesis is false. So the null hypothesis is false. There actually is a difference between the A and B version of the website. What's the probability of missing that effect? So you don't detect it. And the power is 1 minus the beta. As I said before, the power is the probability that you do detect the effect. So it's 1 minus the beta. You don't really need to worry about that. The power is the probability that you'll detect a true effect when there is a true effect. But calculate power using either an online calculator, using R, or using Python libraries. When you calculate the power, I would suggest that you ask for 80% power. That's very typical, and they use a significance level of 5%. Or you can just forget all of that and just use this rule of thumb. And this holds for most website A/B testing, and that's because what really matters is how many conversions you have. So if you know that you have got 6, if you want to detect an uplift of 5%, which is reasonable, if you've made some change to your website, I mean, what we've found is that unless you're giving away free money or saying to people 20% of everything on here, it's very hard to change people's behavior, and a 5% uplift is actually very difficult to get. A 10% uplift you would get if you gave everyone free delivery, and previously they had to pay for delivery, for instance. If you're not giving free delivery or something like that, you're just changing the structure of the website, then you might expect a 5% uplift, and you will need 6,000 conversions to gain good statistical power. This is something just worth bearing in mind. You'll need 6,000 conversions, and you know the conversion rate of your site, so you can just multiply up and figure out how many people need to go through your statistical test. And then if you really think that the new version of your website is guaranteed to, or is very likely to drive lots of uplift because you're giving some amazing offer, you think it might drive an uplift of 10%, then you could move that down to 1,600. But I think you're actually unlikely to see a 10% uplift, so I think it's risky to do that. So it's 1,600 as a minimum. Now, loads of people on the web give you advice about how many people you need to put through your A/B tests. So I'm going to just go through a couple of examples here. This guy says you need 800 to 1,500 successes per version to be seen. Actually, in the original version of this webpage, he said 500. I made a comment saying that this is just not going to work, and he changed it to 800. But these are just, basically, people are just guessing. So this is from one of the main A/B testing pieces of. This is a company who make one of the main A/B testing pieces of software available. They say, I'll read this to you, just the stuff in the red. It says, if your experiment is not statistically significant after 1 month, it's unlikely that additional time will make a substantial difference. So this is like run for 2 weeks, but not more than 1 month is the advice there. So this is not even talking about sample size. It doesn't matter if you've got like 2 people going through your website. It doesn't matter. But then they kind of adapt that and say, we've got this other piece of advice, which is achieve at least 100 conversions per variation before taking action. So it's 100. I think you'll be crazy to do this with less than at least 3,000. And if you use any of those statistical power calculators, you can see that yourself. So 100 conversions per variation. This guy says 150 unique visitors. So that's going to be, 10 conversions, 20 conversions? So don't believe anything that anyone says on the web. And I don't want to be uncharitable, but I think in many cases, these people are trying to sell software, and if they said the truth, people might think, this is very uncharitable, I'm sure this is not the case, but people might think, I don't want to use this software because I will need to use I don't have enough volume in my website. Because most people don't have 3,000 conversions going through their website on a regular basis. It could take months for some websites. So the next thing I want to talk about is multiple testing. So if you run one test, there's a 5% probability that you'll obtain a positive result just by chance, even if there's no difference between the A and the B. If you run 20 tests, you just multiply that, 5%, and you gain one win. So you run 20 tests, on average, you're going to have one positive result, even if there's no effect. So people don't keep track of how many tests they're running, and they encourage their staff to run as many tests as possible. They get lots of false positive results, and then they just congratulate themselves because they think they've got loads of positive results, and they think that they've increased their profits by 20%. So it's quite typical that someone will say, I've increased my profits by 20%, we just did an A/B test and proved it, and then they're really excited, and then they come back a few months later and say, well, it didn't actually have any effect on the money that we're making, so what's going on? So this is from another A/B testing company. You probably can't read this text, but you can see this old guy on the left. He's the guy that runs 1 to 5 tests. He's like the old timer who doesn't know what he's doing. And then you've got this kind of young, cool guy in the cool sharp suit who's running 48 tests because that's the cool way of doing stuff. Obviously, if you run 48 tests, you're going to have 2.5 results just by chance. So don't do that. Or do it, but know that you're going to get lots of false positive results. So on the other side of this is that many companies give targets to their staff. They say, if you get so many positive results this month, then you'll get a bonus or something. So back to this guy. He told me that they had a system where you needed to get, I think it's something, I don't remember the exact numbers, but it was something like you need to get 10 positive tests, each of which needs to have a 2% uplift. So that was the target. Everyone needed to get 10 positive tests. So the simplest way of doing that is just run thousands of tests until you get enough positive results. It's easy. Everyone did it until they figured out what was going on. It's not good. Now, there's another thing which I think is actually one of the most serious things that goes wrong, which is stopping tests early. I think that nearly all A/B testing software is designed such that you should look at the results every day, or it's encouraged that you look at the results every day, and when you achieve a positive result, you should stop to test. Now, in this framework of frequentist statistics or classical statistics, what you should do is run a power calculation, figure out what your sample size should be, run your entire A/B test, and then stop right at the end when you've collected your entire sample size and check the results. So that's the correct way of doing this, and what they encourage people to do, and it's very tempting, is to look at the results every day, stop the test when you have a positive result. So this is what happens if you do that. So I just made some Python simulations. What happens if you run a test for 2 months and you check every day to see if there's a positive result, stopping the test when there is a positive result? This will result in a successful test 41% of the time, even if you're running a simulated AA test, where there's no real difference between the A between the control and the variance. You'll see a positive result 41% of the time. So, this is great because you'll get congratulated all the time on winning tests, but this is an AA test, right? There's no difference between them. And this works out to a precision of 20%. So 20% of your positive results are going to be true positives. The rest are going to be either negative or neutral. And negative means that you're decreasing profits. It's bad. So I'll read this out. Actually, I can't read it. What are we done here? Oh, yeah, OK. So this is, I think what's happened here is that they're talking about running AA tests, and they're saying, some people have said, some of our customers have come to us and said that when they run AA tests, they get loads of positive results. So what's going on? So I'll just go through the titles here. It's like running an AA test, a statistical approach, problems with this approach, and they talk about why there can be some problems, and then what this means and what we're doing about this, where they're trying to figure out what to do. I'm actually going to have a look at this so I can read it to you. OK, so this bit says, I can make it really big. It says, on the minus side, it enables, so they're talking about classical statistical testing, and they say, on the minus side, it enables a well-known methodological error, the repeated significance testing. We believe this is the culprit in some AA tests. So they're kind of figuring out what's going on. And then this bit says, we have been working for some time on evaluating other approaches. But the approach is just fundamentally misguided, in my opinion. So this is just to say that so before I showed you the simulations, there were AA tests. If you have an A-B test with a negative effect, so you're reducing profits by 5% in the variant version, you will still gain a result 9% of the time. So you will still think your variant is actually winning, when in fact it's causing a 5% reduction in your profits. So this is another true story. This person used to work for a large e-commerce company, and she ran an A-B test which had positive results. I won't go into the details because she might be identified, but she had positive results in the A/B test. So they implemented the new version, but they carried on. They wanted to validate the results, so they still maintained a proportion of people in the control group, just so they could test that the A/B test was actually genuinely effective, which is a really good idea, by the way. So she did this, but she didn't bother looking at the validation results. She didn't bother to keep monitoring the results of this validation phase. She just assumed that the A/B test, because it was originally a win, would carry on generating profits. They realized that there was actually, on the validation phase, after a few months, she casually checked the results, and she realized that it actually had a negative effect compared to the control. So it was reducing profits by around 5%. But this is a really large e-commerce company, so she kind of figured out how many days it had been running and the traffic and how much money she had lost them, and it was £1.5 million. So she was really upset, and she wanted to remain anonymous in this for obvious reasons. So this last thing is regression to the mean. So this is interesting, I think. So this is regression to the mean is what I'll give you an example. I think this comes from Wikipedia actually, so you can look at that article on regression to the mean. But this is an example. You have 100 students. You give them a true or false test, so they can only answer true or false. They all answer randomly. Obviously, their average score is going to be 50, right? Half of multiplied by 100. Now you take the top scoring 10% of the class. And now these guys are not the most intelligent or anything else. It's just completely random data. If you test them again, they're just going to answer randomly again, and they're going to have an average of 50 again. But because they were top scoring, they would have had a high score to begin with. And so you'll think, well, why did they used to be really intelligent? Their average was 90% or something, but now it's 50%. What's going on? This is what regression to the mean is, this kind of classic statistical concept. But we see this all the time in A/B testing. So this is, I was talking about a validation test. This is an A/B test, and I've plotted the uplift on the test on the x-axis. And then we perform a validation test, and I plot the uplift in the validation, or the production, on the y-axis. And this is simulated data. And this is simulated with no effect. So this is a random effect. And like I said, 1 out of 10 tests are going to have a true effect. So 9 out of 10 tests that you run are going to be effectively random data. There is no effect in 9 out of 10 tests. So I think this is quite useful for the majority of A/B tests. So you can see that the uplift for the winners in the test is really high, like the average is 20%. And the uplift if you select those people, put them into production, but also maintain a control group so you can still test what their uplift is in production, you'll see that the average is now going to be 0. Does that kind of make sense in this graph? You think they've got really high uplift, but then when you run the test again, you realize their uplift has dropped down to 0. So you think, well, they used to be really effective, but now they're not so effective. What's going on? The fact is that people are running such tests with such low statistical power that they're just seeing false positives. I've told you, early stopping, multiple testing, lack of power is going to cause lots of false positives. So obviously, when you run a validation test, the effect is going to drop down to 0 because these are just fictions. They're not real effects. But I don't think people really understand this in the industry. So I'll show you this. This is a blog post where someone's saying, they're talking about the roller coaster ride of statistical significance. And they say, if you're involved in website testing, you've likely experienced this in the form of tests that gain and then lose statistical significance. They're talking about this effect where you run an A/B test, you have a high uplift, and then you run another A/B test on the same A and B, control and variant, and the effect goes down. And they try to explain this with this paragraph at the end. So what happened? Your test experienced the novelty effect, or the roller coaster ride of statistical significance. And what they're saying is that what's happened is that people respond to novelty, but then the novelty wears off, and then they don't respond to that re-offer or whatever. And that's just, I think, a much simpler explanation for this is that they're running very low power tests. These are the guys who said you should run 48 tests at a time. They're running multiple tests, low power, encourage early stopping. All of their many results are going to be false positives, in my opinion. You would therefore expect to see a drop in uplift after running validation. So that's the same graph again. So there's this kind of related effect, which is that even if there is an effect, you're likely to overestimate what the degree of that effect is. So even if there is a true uplift of, say, 5%, you're likely, by a phenomenon called the winner's curse, you're likely to see a bigger effect when you actually run the test. So don't believe the actual effects that you see. If you see a 20% uplift, that result is very likely to be false. And you should be very skeptical of all of the uplifts that you estimate from this kind of test. It's a very well-known statistical effect that the true effect is likely to be much lower than the observed effect. So uplifts of estimates of uplift are generally wrong. So this is what you should do to get it right. Do a power calculation first to estimate sample size, always. Use a valid hypothesis, don't use a scattergun approach. And this is like, you probably heard these stories when people have said, we had a call to action, like the purchase button. It was green, and then we changed it to yellow, and then our profits went up by 10%. We did an A/B test, and it was like 10% uplift in profits. That's what I mean by not a valid hypothesis, because people just don't buy more stuff just because you change the color of a button. And these scattergun approaches just don't work. Don't stop the test early. Run it to completion. It's perfectly fine to have a look at the results, but you need to wait until you have the full sample size that you started with. And then to be robust, you should perform a second validation test. This will solve all of your problems. If you're subject to any of these problems, if you run a second validation test, it will reveal that the first test was just badly run or that there was a problem there. So that's it, really. These are my details. You can get the slides here. That's a Google shortener, JVHWM capital B, if you want them. And feel free to get in touch. So this is stuff that I did with my previous employer, Qubit. I'm now working at Skimlinks. We're also doing lots of very cool data science. Any questions? So I think the question, correct me if I'm wrong, but I think the question there is, what happens if you redesign your site? There probably is going to be some genuine novelty effect. If you do a validation test, how do you make sure that there's no confounders between the fact that the validation test is going to be full of people who have already seen both versions of the site? There's going to be some complexity in the two groups. Is that right?
Well, no, maybe the validation set is exposed to people who have mostly not been exposed to the new site, and they're still excited by the yellow rubber button. Okay. Which is not a true effect, not a long-term.
Yeah, so there's some complexity here. I think the answer to these kind of questions is a cohort study. You should only look at new visitors to your site, for instance. Everything's much clearer if you do that. There's no complexity due to people who are having already been to your site. But again, make sure your power is good before you jump to those kind of conclusions. Go ahead.
Did you have any distributional assumptions on the data?
So there are lots of different ways that you can do this. You can model this as you can model the number of purchases that someone does as a binomial distribution, depending on how many visits that person has had, or you can just model how many purchases were made on. If you want to do a simple model, then you might make an assumption of a Poisson distribution for the number of purchases that have happened for each group. Lots of people do things like binomial distributions for the number of visits. So how many times do people purchase per visit? And then they'll make a Gaussian assumption, typically. Yeah, go ahead.
You tried anything with bandits instead of split tests, and how do they behave at low power?
Yeah, so I haven't done any work with bandits on this, and it's a very interesting question. So the question is how do bandits work in this context? And the reason why I haven't really been that interested in the bandit methodologies is that I'm really interested, and in many cases marketers are really interested in what really had an effect on their site. Like they want to know if I change this, or if I run this special offer, then what's the real effect of that special offer? And this is like, they can work out how much profit they're going to make for the year if they do this. So if you want to bound it, it's much harder to get those kind of statistical guarantees that you can get from classical statistics, where you can say what the confidence interval is and that kind of thing. But I think it's an interesting way forward, and there are methods of doing this. And so there's Thompson sampling, if you're familiar with that. And if you use some Bayesian methods, then actually lots of these problems go away if you use Bayesian methods. Things like early stopping is fine. But I think it's important to remember that in the end, someone wants to know what the result really was, and they want to know what the statistical guarantees were. Go ahead.
I have a question about using power to calculate the minimum sample size.
Mm-hmm.
Am I right in understanding that it works only if you measure simple metrics like conversion? If you want to measure revenues per user, can you still use?
Yeah, so some people, so the question is, how do you measure statistical power if you're doing something a little bit more complicated? You're not just looking at conversion rates, but you're looking at revenues, for instance. Lots of people just do simulations for that. They just do Monte Carlo simulations of revenue, and that's very big. So in medical research now, Bayesian testing is becoming more prevalent. And for Bayesian testing, there's no convenient ways of doing power calculations, so people tend to just do simulations. So.
Have you actually analyzed uplift in revenues, or were you mostly looking at?
I've looked a little bit at uplift in revenues, but mostly in conversion events. Yeah, so like simple things that you can do, like obviously the distribution of revenues is going to be the normal assumption is not going to be valid, so you need to have a think about that. Anything else? Go ahead.
You say that you should just run tests on reasonable assumption, reasonable hypothesis. How do you decide if it's reasonable or not?
It's a good question. How do you decide what's reasonable or not? I think that marketers, if they really trust themselves, they really know what they're doing. They should. I don't think that you can trust the data for everything. You should trust your experience and your education, because people know how to sell things to other people. They've been doing it for thousands of years. I think the idea that you can just randomly change your website until some mud sticks and eventually you'll find something which improves your revenues is just false. I mean, the real way to improve profits is by having a good product range, having good prices, and those are the kind of things that marketers have been doing for years.
But I read an article, for example, they were testing two different buttons for an Obama campaign. And so maybe a marketer can see this and say, oh, maybe it's a good idea, let's try it on our website. So, yeah, sometimes it's difficult to...
I mean, it's fine to do it, but just make sure that you have good statistical power and that you're not making some of these other errors. Test it, and I mean, maybe you do have an effect, but if you do see an effect, run a validation study to make sure. I should say that most of my experience is with large e-commerce retailers, and the fact is that checkout and the web design is normally really good on these sites already. It's just very difficult to change behavior just by improving the site. So this is, I'm not saying that this generalizes to all A/B testing, but I think it's an important point to make. Yep.
So on the back of your experience and accepting that there aren't that many quick wins to be had, when you've spotted some quick wins, there's probably a bunch of them on bad websites. What would they be? Come across?
Well, free delivery. Giving people free money is always a good thing. There are some cases where you've got real problems with the website design. Sure, like you get to you try to go to the checkout and they ask for your email address before you can actually buy anything, and that just annoys people, that kind of thing. But really, it's pretty hard. I mean, things like changing the product range and giving people free money is really what works.
In your experience, how controlled is the control in the A/B testing? I'm just imagining that a commerce site has lots of A/B tests going on at the same time, and how do you control if someone's trying thousands of tests?
So, like, standard practice is just to not worry about it. You just run loads of A/B tests and just assume that everything averages out. You are running on millions of different people, so I think that's a valid assumption. If you then, I think that's the only thing you can do. If you try to do multivariate testing, then things become very complicated very quickly. If you do see a result, run a validation study.